Welcome back to TechShare channel. In this session, in this Java general discussion session, I want to discuss about one of the most important topic in the world of threading mechanism in Java. This is about the keyword synchronization and about a locking mechanism in the multi-threading environment. So yeah, so let's get into a discussion. So thread was the one of the part of Java since Java 1. Like we have a lot of libraries. Like initially we need to extend thread to create a thread, and later they added interfaces like callable, runnable. So and then we have executor frameworks to create that thread and submit a thread. So these are different varieties of how to create thread in the multi-threading environment. So how to create a multiple threads. So these are different ways they keep adding, and each of these ways has its own pros and cons, and we need to use one of these to create a thread. Depends upon our requirement. Okay, so but we are not going to discuss about how to create a thread, but we are going to discuss about how to share the data between multiple thread. Okay, so that is the primary objective of this discussion. So here so there are multiple ways. Okay, so one of the way we all know using the synchronized keyword. Okay, so which is a traditional way. Like we can synchronize a method, or we can synchronize a block and synchronize the object of a current class, or synchronize using some object, right? So these are the different ways. So what is actually happening here, once a thread enters into the synchronized block or method, okay, so he wants that that object. Okay, so basically every object will be having a lock. Okay, so internally every object should be having a lock. Okay, so whoever owns the lock, okay, will be owning the object, so no other threads can actually acquire that lock unless someone released the block to lock. Okay, so that is a concept at high level. So let's say like I have a thread T1 to T10. Okay, so the thread T1, which comes first, and it got this particular object, and it got into this synchronized, means the thread T1 has the lock of this object. Okay, so now let's say that thread T2 or T3 or T10, okay, want to execute this block, then they have to wait for the thread T1 to release the object. Okay, until those thread will be waiting. Okay, so as per the life cycle of thread, okay, those thread will be in the runnable state. Okay, so once the thread T1 released a lock, one of the thread from T2 or T10 can get a lock of this object and can start executing. Okay, so that is how the locking mechanism works using the synchronized keyword. So what is the drawback of using the synchronized keyword? Yes, okay, so as I said, okay, when one of the thread enters into the synchronized block, okay, the other threads from T2 to T10, right, they have to wait, right? They are blocked from proceeding what they want to do, right? So they have been stored in they are actually utilizing the Java memory. So we are blocking those thread, okay, to complete their operation, right? So because of this, you can see a lot of performance issue. Okay, in your program, right? So that's all because of blocking all those threads which are waiting for a thread. So the major problem here is the performance issue because of too much threads are blocked from executing, right? So that is one of the issue. And the another issue is, okay, let's say so we all know that thread T2 and thread T10 is waiting to get a lock, right? So let's say that thread T1, okay, released a lock, okay, but we cannot guarantee which one of these particular thread, right, T2 or T3 or T10, which is going to get into going to own the object, right, the lock of the object, right? We don't know, right? It will be randomly given, okay. So since it is going randomly, there is a high chance that one of the thread may not get the opportunity to work. So it's called starvation in the thread world. Like he is just keep waiting and he's not getting the lock, okay. So this is another problem here, okay. So to overcome all these problems, okay, that is why they started introducing the locking, okay, mechanism. So they introduced the library called ReEntrantLock, okay. So how to implement the lock? It's very straightforward, okay. You just need to create a lock object. So once you say, okay, lock, so you got a lock of that object, okay, and when you say unlock, you are just releasing the lock of the object, okay. So that's a straightforward, okay. Getting the lock and then unlock. So what's the difference between this and this? Nothing. They are both same, right? Here you are not here. Here it is happening internally. Like once it is get into the synchronized block, you are getting the lock. Once it is going out, the JVM itself will be releasing the lock. So everything is taken care by the JVM. But in this case, you have to you are trying to lock explicitly, and it is your responsibility to make sure that you are releasing the lock, okay. If in the case, like if this particular line is not executed, if the unlock is not executed, then you're going to be in a big trouble. So that is one of a very critical point to note when you are using the lock, okay. Make sure when you lock, you also doing the unlock, okay. So you need to do multiple testing to make sure the unlock is always executed, okay. That is why it is recommended to put the unlock in a finally block, okay. So let's get back to the point, okay. So as I said, like what is the difference between this and this? There's nothing, right? So how are we going to overcome all these drawbacks we discussed about the synchronized, right? There is a way to do that, okay. Let's say, okay, I am going to use the try lock, right? So in the try lock, what this do, okay, this is not go, this will try to get a lock, okay, until this much of time. If it is not going to get a lock, okay, if it is not going to get a lock, if this lock occurred is false, okay, then it will skip this if condition and just proceed to execute the rest of the statements and just complete. Like what we trying to do here is, okay, let's not hold the thread in the memory, right? In this case, we are holding all the thread in the memory. In this case, we are allowing them, okay, not to wait for the lock. Instead, just go and finish your job, right? So that is one of the major advantage of using the try lock. Okay, there is also a way where we can forcefully, okay, interrupt, okay, so let's say in this log, okay, let's say the thread T, okay, we want to design in such a way, we want to design our program in such a way, the thread T3, okay, at any case, okay, it need to get the access to this block, okay, at any case. If someone is doing the job already, you want to kill him and this guy want to do the job, so that is the requirement, okay. In that case, we can achieve that using the logging mechanism. We have a interrupt log, okay, interrupt log, which actually can interrupt the thread which owns the log now, okay. It can kill that thread, it can interrupt that thread, and it can start executing, okay, as an exception, interrupt exception. So that is another way. So what we are trying to achieve here using the try log and interrupt log is, okay, we are making sure, okay, no thread is waiting and we are not holding anyone in the memory, okay, to get a better performance. Okay, and on top of that, we do have something like, okay, on top of that, okay, so the other point which we discussed here is about the starvation, thread starvation, right? So there may be a chance that one of the thread may not be getting chance to do his job, right? So even that can be achievable using this log, right? So when creating a log, okay, there are a way to pass in the constructor telling, okay, when I unlock this object, okay, give chance to someone who is waiting for a long time. So that way, if the JVM says that T3 is waiting for a long time, then the chance will give to T3, okay. So that is the way, like, we are trying to give more fairness to one of the thread which is actually waiting for a long time. So we are using the log, we actually getting more control, right? With the synchronized keyword, it's like we don't have a control, like everything we are asking the JVM to do it, right? But in this case, we have a control, a lot of control to do, like some of the things, right? And yeah, so another one is the major advantage of using log is using the re-entrant read-write log. So with this, what happens, okay, this is also achievable using this synchronized keyword, but we have to do a lot of, we have to write a lot of code to make sure these things is happening only as per requirement. That need a lot of exercise, okay. So what we actually going to achieve with this read-write log, okay, with the read log, okay, this will make sure, okay, no thread is currently writing on that particular object, okay. So the write log is not occupied by, owned by any thread. So that is a read log, okay. So if in that case, okay, any number of thread, okay, can go and store the data in that particular object. So that is what, how read log work, okay. The write log, okay, how it works, okay, it will make sure no one is reading, okay, and no one is currently writing. So it will allows one of the thread to write, to modify the object. So that is what a write log, okay. So this is achievable, this particular function is achievable easily using the re-entrant read-write log, okay. This is also achievable using the synchronized keyword, like using the notify, wait, all those the traditional ways of communicating with the thread. But you know, there is a lot of coding involved on that, right? So instead of that, we can make use of this read-write log to implement that particular functionality. So it's giving a simplicity for us, right? A simple way of locking the object, okay. So apart from all these advantages which we discussed, okay, it also providing us some of the methods, like if we want to know how many thread is currently running, how many thread is currently waiting, how many thread is currently holding the object, sorry, how many is held by the current thread. Like if there is any, if this particular object is held by the current thread, or if this particular object is already locked. So all these features like we are getting as part of the locking mechanism. Okay, so we can make use of all these features, like to write more efficient coding, right? Like to implement more efficient coding, we can use all these features to implement more efficient coding. So that is one of the biggest plus of using the lock mechanism. Okay, so but the lock itself has its own drawbacks, because when you are switching between multiple thread, okay, that involves a lot of context switching, okay, which is really a very expensive operation on the JVM side. Okay, so if you are doing too much of switching, too much of logic using the log, then you may see some of the performance issue. Okay, so in general, what I learned, okay, if it is a very simple requirement, go with a synchronized. If it is a complicated and if you want a more control on the locking mechanism, then go with a lock. So so I think that's very clear. Okay, when to use the synchronized, when to use the lock. Hope you guys good with this. If you if you guys think like I am wrong in some perspective, please add your thoughts in the comment so I can correct myself. Okay, and if you guys like this video, subscribe to my channel so we can have a lot of healthy discussion in the future channel. Okay, thank you. Bye.